Okay, one other note about different transformations in the coordinate plane. So again, these transformations, they're just some sort of a rule that moves points from one place to another. And a lot of these transformations will move whole shapes. And when they move them, and they keep the shapes the same size and the same quote-unquote shape, they create congruent figures. All right, and some of these are, let's see, glide reflection, reflection, and rotation. So rotation is a turn. That's what it sounds like here. So for example, from triangle ABC to triangle, let's see if it was ABC, B, D, E, F, I think. Yes. Losing my mind here. So from ABC to D, E, F, this is a rotation, and the rotation has a center of rotation. In this case, it's point C. So the center of rotation is like, for turning something, it has to have some center at that turn, and there's always some point. In this case, it's C. So this whole triangle, you can imagine just sort of turning everything with C as a rotation, and we get this resulting triangle over here. That doesn't have to be, by the way, a point that's on the triangle. Here, for example, these two triangles are rotations of each other, with this being the center of rotation. Okay. The key about the center of rotation is when you turn something, notice how that point there and this point here, they are the same distance from the center of rotation. So as things turn around, or for example, this point right here and this point right here are also the same distance from the center of rotation. So you kind of imagine, right, that was the turn there, and this one here, something like that, and there's our turn there, and that the angles that they turn are the same for every point. Anyway, so that's a rotation. Next we have a reflection, which it's kind of like a mirror image. A reflection always has a line of reflection. In this case, it's been flipped across this horizontal line here. Horizontal and vertical reflections are common because they're easier to calculate, but it doesn't have to be horizontal or vertical. We can reflect across any line that we want. And the key is that when you reflect across a line, the point, the pre-image, the before point, is always the same distance from that line as the image or the after. So when this point gets flipped across, in a sense, flipped across that line of reflection, its reflected image is always the same distance from the line of reflection as the original was. So this point here, down to the line of reflection, and this point up to the line of reflection, same distance, by the way. Ignore this, it was a righto. All right, or this point here, C is the same distance to the line of reflection as H is. So when the whole figure gets flipped across, every point is the same distance from the line of reflection as its image, or as its reflected image is. And when we talk about distance, of course, it's always that perpendicular distance straight to the line. The other one is the final one is a glide reflection. I think it's like glide and reflect, glide and reflect. All right. So what's happening here is it's a mix of a translation and a reflection. So for example, this shape here has been moved. It's been moved backwards here, and then it's been reflected across this line right here. So B went back to this point here, and then it got moved down to J. A got moved back, and then when A is reflected, it doesn't go anywhere because it's right on the line of reflection. And C got moved back to here, and then it got moved across the line of reflection. So here you can see kind of here, So this triangle here was moved straight back to here and then reflected across that line. So that is a glide reflection. A glide, like it slid and then it flipped. And those are three other different types of transformations that we can have. Three different ways of moving shapes in the coordinate plane, or better yet, to think about it, it's a function. We feed points into it and it outputs new points. And for some of our transformations, we are going to have actual coordinate rules that we can follow for how to do those instead of just drawing pictures of them in the grid. Okay. But anyways, again, glide, reflection, reflection, rotation, they all kind of do what they sound like a little bit. And it's usually not too hard to identify which one's which. Again, if it's a rotation, every point is going to be the same distance from the center of rotation as its image. If it's a reflection, every point is going to be the same distance from the line of reflection as its image. And then glide reflections, they're a little bit trickier to figure out. If it's not a strict translation, reflection, or rotation, look to see if you can figure out maybe it's a glide reflection. What was the glide part and then the reflect part.